This is section 9.4, Formulas and Applications. We have worked some of these problems before. We did some applications to quadratics. We talked then about how you often get two answers, but sometimes one of them won't make sense in the real world. Like you'll get a positive answer and a negative answer, and you'll have to throw out the negative 14 in this case because it doesn't make sense in the real world. So we just need to be aware of that as we go along. But, we're going to set up quadratics in all of these. We should be able to get them solved. Okay, so let's look at this. We have a right triangle, and we are asked to solve for m. If you have a right triangle and you're talking about lengths of sides, you're almost certainly talking about the Pythagorean theorem. And remember that these two sides, the ones that make up a right angle, these are called your legs. And in the formula, they are A and B, and it doesn't matter which is which. Okay? And this side, the hypotenuse is always C. And then the formula for for Pythagorean theorem is A squared plus B squared is equal to C squared. So let's plug in these values. A is n, so n squared plus p squared is equal to m squared. So this is our starting formula. We want to solve for m. I have m squared by itself equal to, we assume that these are numbers that we know. Okay, so I'm going to flip this equation around just because, well, personal preference, but it bugs me when it's the other way. So let's take the square root of both sides using the square root property here. And when I take the square root on this side, I have to use a plus or minus. So I get m is equal to plus or minus the square root of n squared plus p squared. Okay, if we were given this and we were asked to solve for m, this would be our answer. We were not given this, we were given this. And our m is definitely a distance. It's some sort of length. Right here, it doesn't really matter what these two numbers are. You square them, you add them together, you take the square root of it, you have a positive answer in here. This positive here will give you an overall positive answer. The negative here will give you an overall negative answer. Negative answers don't make sense here, so we throw away the negative. Okay, so the answer we're looking for, because we are in the real world, is m is equal to the square root of n squared plus p squared. We don't need to keep the positive sign once we drop the negative. It's understood to be positive. This is the answer they'll be looking for. Okay, so let's try this one. It's very similar. We have a right triangle. We are asked to find m. And we have the most important one to identify is C, and C is the one directly opposite your right angle, so this is C. It doesn't matter which one you call A and B. Those don't matter, okay? Use the Pythagorean theorem, and remember when you're squaring something, you have to square the whole thing, so parentheses, especially here, are going to be necessary. But I have 3m squared plus 2m plus 14 squared is equal to 5m squared. Okay? Remember when you're squaring two things that are multiplied together, you have property number 8 right here, and we need to put this exponent on each one. So right here, this is going to be 9m squared, and over here that happens as well. But it does not happen right here, and that's because we have the plus sign in the middle. We have a perfect square trinomial situation, and so we need to follow this formula for this one. That plus sign makes all the difference in the world. So if you're following this, you square your first term. So if I square all of this, it's going to be 4m squared, okay? That's a plus, so I write a plus. And then I multiply these two things together. 2 times 14 is 28, and then we double it. So you multiply them together, and then you double it. And so you get 56. So this is plus 56m plus 14 squared is 196. All right, and this is equal to, I'm going to put some parentheses in here just to make it a little bit clearer where things came from. Mathematically, they don't make any difference whatsoever. So this one comes from here. All of this comes from here. Now, square the 5 to get 25, m squared. Okay, so I need to get my m by itself. So I'm going to, what can I do? I can combine these two. Let's do that first. So that'll be 13m squared plus 56m plus 196 is equal to 25m squared. Okay, so I see that I have an m squared that's not going to cancel out. So I'm going to need to use factoring, the quadratic formula, something to get m by itself. And on all of those cases, it's easier if the number in front of your square is a positive number. So I have two options here. I can subtract all of this over to this side, because if I subtract the 13 from the 25, I'm still going to have a positive number. Or I can subtract 25 from over here and then multiply everything by a -1. Okay, so let's do it that way, because I rarely do it that way. So let's move this over here. 13 minus 25 is 12. So this is, well, -12m squared plus 56m minus 196 plus 196 is equal to 0. Okay? Now, if I look at this, there's actually something I can do here that will make my life easier. I can multiply everything by a -1 to get rid of that negative, which is something I would need to do no matter what. But I also notice that all of these numbers are even, which means instead of multiplying by -1, I can multiply by a -1/2, or I can think of it as dividing by a -2. That'll give me the positive number here, and it will make all these other numbers smaller. Well, the truth is you can even do better than a 2. Everything here is divisible by a 4. I'm going to divide everything here by a -4. And when I say everything, I'm including that 0. Okay? Because this trick doesn't work unless everything on both sides is divisible by that. Okay? Now, when I do that division, I get 3m squared minus 14m minus 49 is equal to 0. Okay, so now I need to either try to factor this or maybe use the quadratic formula, or I'm not going to choose to complete the square. Now, my general approach when it's just, hey, solve this quadratic, the first thing I look for is factoring. If it factors easily, that's the quickest way, and I go for that. Then I ask myself if it's in the right form for the square root property, and this is not, because square root property is the next easiest thing. And then after that, I go to the quadratic formula. Now this might factor, it might not. I would have to multiply the 3 times the -49, try to find two numbers that multiply that, hope I can find some that add to -14. It might take a while, and then I might find out at the end this doesn't factor at all. So I'm going to go for the quadratic formula. Okay. So, m equals -b. My b is going to be -14, so this is positive 14, plus or minus the square root of b squared, so -14 squared, minus 4 times a times c, so this is times 3 times -49. And this is all over 2a, so 2 times 3. Okay, so inside I have 14 plus or minus, it's going to be the square root of -14 squared is 196. Okay, so, and this is minus 4 times 3 times -49, So this is plus 588 over 6, which is 14 plus or minus 196 plus 588 is 784 over 6. If I use my calculator, I find that this square root is exactly 28. So I have 14 plus or minus 28 over 6. So since I ended up with a perfect square here, that tells me that this thing would have factored. It just might have taken me a while. Now I do want to split it up and get my two answers. I have, if I do 14 minus 28, I get negative 14 over 6, which reduces to negative 7/3. And then I would have, if I did 14 plus 28, I get 42 over 6, which is 7. So the two answers to this equation are negative 7/3 and positive 7. But we weren't given this, we were given this. Okay? Now, just because we have a negative number does not necessarily mean it's bad. There are ways that these sides could be written where that would be a perfectly good answer. But, you know, we have to look back here. But if I take this, it's just even it just being a negative number, multiplying a positive times a negative is going to give me a negative answer. So that is not going to make sense for here. Now, just like this is not necessarily bad just because it's a negative, this is not necessarily good just because it's a positive. We do need to make sure that it makes sense on all these sides. That's going to be 35. This is going to be 21. So those are both okay. And then this would be 14 plus 14. So that's also positive. So that's okay. So in this case, your answer is m equals 7.